So last class we did the ax squared plus bx plus c, but a equals 1. But this class, a does not equal 1. So that makes it considerably more difficult to do most of this factoring. Okay. You know, I call it, when a equals 1, I call that simple quadratic trinomial. And then I call this not simple. I guess I could call it like complicated or use another word, but that's just what I've always called it. The book doesn't call it that. You know, as you could see, they call it ax squared plus bx plus c. So I'm going to show you two ways to do this. And one way is really, the book only shows one way. That's the first way that I'm going to do right here. But for most of you, I think you'd rather have another way to do it. And I think you'll see why. So if we have to find two binomial factors that multiply together to give us 3x squared plus 20x minus 7, I need that to be blue. Go back over here. There we go. You know, we can bet that the first term in each factor, one of them's got to be 3x and one of them's got to be an x. Right? Because how many factors does 3 have? Just 3 and 1, right? I mean, there's really no other options for that. And because the first number is a prime number, that's good. That means this method of solving, guess and check basically, would work for us. Okay, well, what are the possibilities for the factors of -7? Because we know that the last two numbers are going to multiply to give us the -7 when we FOIL. So what are the possibilities here? -7 equals 1 times -7, or -1 times +7. I mean, it's got to be one of those two, right? And we don't know which one would go in which set of parentheses, but it's only 4 possibilities here. So this is the guess and check. You know, we could, for example, I could say that let's make this -7 and +1. Because for sure I would get the 3x squared as the first term and the -7 for the last term. But would I get the right middle term? Well, what would be the middle term if I FOILed these two? Right? You would get a +3x and a -7x, which is 4x, and that's not 20x. So that's not it. Okay, what if we did 3x plus 7 times x minus 1? Right? What would be the middle term? We would get -3x plus 7x. Actually, I think this one was a -4x, and then this one is the +4x. In either case, neither one of those worked. So we know now we need to switch those numbers around. What if we did 3x plus 1 times x minus 7? What would be the middle term? (3x times -7 plus 1 times x). What is it? Yeah, that would have been -20x. That's wrong because we need it to be a positive 20x. Well, we just tried 3 out of the 4 possibilities there. So what has to be the answer? 3x minus 1 times 3x plus, oh sorry, not 3x, x plus 7. And that ought to fix that sign of the term. Okay, now what do we get when we do the FOIL? We'll get 3x squared plus 20x plus 21x minus 1x minus 7. That's it. Right? So, I mean, that is called guess and check. And it's particularly useful if you've got like prime numbers for the A and the C. Then there's not that much guessing to do. What if they're not prime numbers? Well, then there's a whole lot more, you know, things you got to consider. You know, what if you ended up with like a 24 in one of those positions that's got 1 times 24 and 2 times 12 and 3 times 8 and 4 times 6. I mean, that's a lot of checking, especially if there's sign changes and things like that. But anyways, let's try a guess and check. You try right here. So, I mean, we don't have many possibilities here, right? The first terms, I mean, we always start with positives. So let's say 5z times z, that'll give me 5z squared. And there's only 2 possibilities for 3, right? We could make it 1 times 3 or 3 times 1. And you just have to play with it to see which one gives me the right middle term. It's always about the middle term. And which one was it? It should have been 1 there and 3 there. Okay. Now you can see that you get 5z times 3 is 15z plus 1z, there's your 16z. Now, again, if it says to factor, factor. Don't try to solve an equation. There is no equation there. You're going to lose points on a test if you factored that correctly and then you wrote off to the side the answers. There are no answers. And if you understood it better, you wouldn't do that, right? So you're kind of betraying a little bit of, I don't really know what I'm doing, I'm just following these steps. Okay, you need to understand if it doesn't say solve and there is no equal sign, there is nothing to solve. Okay, now, let's say we had to do this one. And this one is 5 is still a prime number. 6 is not, okay? 6, at the very least, I would have to check 1 times 6 and 2 times 3. And then they could go in different positions. I could tell you that since the last number is positive, I know that they're either both positive or they're both negative. But since the middle term is negative, they are both going to be negative, okay? So that at least eliminates some of the having to change signs to see how it goes. But if you don't want to guess and check this, this is the process that you can actually like systematically do this process. But it does take, depending on how you count, 5 or 6 steps to get it done. All right, and this is how you do it. You remember the ax squared plus bx plus c, right? That's the standard form quadratic expression. Okay, you multiply the 5 times 6, the a times the c, right? And you get 30. Okay, then you find the factors of 30 that add up to negative 17. Okay, that add up to the middle number. So we're not just looking at the c now, we're looking at a times c. Okay, well let's see. 30 has factors of 1 times 30, 2 times 15, 3 times 10, and 5 times 6. All right, and both of these numbers could be positive or both negative, but because it's a negative 17, I'm going to say they're negative. Yeah, it's going to be the negative 2 and the negative 15. Okay, so once you find what those two numbers are, right, then you're going to split up the middle term. Right now the middle term is negative 17x. We're going to make that negative 2x minus 15x. And then we still have plus 6 and 5x squared in the lead. Okay, so all I've done is rewrite the middle term using those two numbers. You know, negative 2x minus 15x, that is negative 17x. So I didn't change the value, I just changed the format. Okay, next step. Group the first two terms in parentheses, 5x squared minus 2x. Okay, and then you need the subtraction symbol, which is in front of the 15x. That is a subtraction that goes in front of the next set of parentheses. 15x minus 6. Okay, now why did I change the sign of plus to minus when I introduced parentheses? Yeah, the negative in front of the parentheses is actually going to flip that sign. Right? That negative is going to make that negative 15x plus 6, and that's what we started with. So when you have a subtraction symbol, that's not a multiply times a negative, that's a subtract. When the subtraction symbol is in between the parentheses, you've got to flip the sign of the last term. You have to remember that one. Okay, next step is you have to greatest common factor each set of parentheses. Okay, what's the greatest common factor in the first set of parentheses? x, right? Okay, what's left if I factor out x? 5x minus 2. Okay, and what's the greatest common factor in the second set of parentheses? 3. Both divisible by 3, and what's left inside the parentheses? 5x minus 2. So if you've done this right to this point, what's in parentheses should be the same. If it's not the same, you did something wrong. Okay, now that's two terms, right? And they're separated by that subtraction symbol in the middle. What's the common factor between those two terms? Right? Each one of those terms has got what in it? 5x minus 2. So you can factor out the 5x minus 2. And you can do that to the right or to the left. You know, most of the time they usually show this to the right. 5x minus 2. And then what was left behind when I took away the 5x minus 2? X minus 3. Right? This is the x that was left behind, and here's the minus 3. So that was like how many steps? If you count it as a separate step when you multiply 5 times 6, that's 1. Then you found the factors of 30 that added up to negative 17, that's 2. Then you split up the middle term, that's 3. Then you grouped, that's 4. Then you had 2 factoring steps, 5 and 6. So it's like a 6-step process. Now, if it's easy to guess and check, then you guess and check it. But if it's not, you have a process that you can get it without guessing. You can get the right answer. Okay. So try to factor that one like we just did there. Okay, and let me remind you with the steps that are right here. Okay, 1, find the factors of AC, that's a product, whose sum is B. 2, split middle term. 3, group first 2 terms, last 2 terms. And then 4, GCF factor each parentheses, and then one final factor. I see quite a bit of like either you're done, you've finished it, or you're still working on what are those 2 numbers. So how is it that I told you again you can use the calculator to find all the factors? Find all the factors of negative 36. Well, let's say 36 first. Remember, go in your calculator, put in on the first line, put 36 divided by x, and then go to the table of values. And then you can see right there, it's 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5 is not a factor, 6 times 6. And at that point you're done because the numbers in the left column get bigger than the ones on the right. Now since it's negative 30, that means one of them's got to be positive and one of them's got to be negative. Which is going to be the positive? The bigger term's got to be the positive. Okay, quiet please. Let's get back to this. So again, the factors of 36 are all on the screen there. Now by making the bigger one positive and the smaller one negative, which one of those pairs is going to add up? 9 and negative 4, right? So let's say that I pick out my 9 and negative 4, and then I come over here, I write down 3x squared plus 9x minus 4x minus 12, right? And then what do I do next? I group the first two, group the last two. So I'm going to write like this, 3x squared plus 9x minus 4x plus 12, right, because of the minus in front of parentheses. Now, what's the greatest common factor in this first set of parentheses? 3x times x plus 3. And then what's the greatest common factor? 4 times x plus 3. And now we've got x plus 3 in both sets of parentheses. So it's x plus 3 and 3x minus 4. Yes. So here's the thing. I'm going to do it again. How many of you put the plus 9x minus 4x in that order, like I did? How many did the opposite way? Okay. Now, you got the factors switched around, but...
Hi. May I see Kirsten Clark in guidance, please?
Yes.
Thank you.
So because of that thing where when you've got the minus in front of parentheses, that could lead to an error, right? Because you forget to flip the sign of the last term. That's why if you've got a plus and a minus, it's usually better to put the minus first, right? If I go, instead, if we did it like this, 3x squared minus 4x plus 9x minus 12. Now when I group, it's a plus in between the parentheses, and so I don't have to worry about flipping the sign. In fact, I can group it on this same line. I don't even have to write a new line. So, I mean, you don't have to do it, but that would save you having to flip the sign of the last term. And then x times 3x minus 4 plus 3 times 3x minus 4, and that is x plus 3 times 3x minus 4. Okay? So, if you don't like guessing and checking, and this is a very systematic way to find your factors. Okay. Okay, well now we also have to deal with our special factoring patterns. That last class, when we did them, they always had a equals 1, but now they don't. So remember the difference of squares is when you've got something squared minus something squared. Okay, is that what we have? 9x squared minus 64? It's not quite, but we should recognize both 9 and 64, those are perfect squares. So I could write this as a difference of squares if I would just rewrite it like this, right? Parentheses, 3x squared minus 8 squared. Okay, now it is a difference of squares. Okay, and how would that factor? 3x plus 8, 3x minus 8. So when you have 3x, a product, inside parentheses, and you've got an exponent outside, you can distribute that exponent to the 3 and to the x. That's why that works. If that was x plus 3 squared, you can't do that. But when it's a multiply inside, you can. All right, so difference of squares. I think the next one is for you. So try to do that, try to factor that. So anybody get the factors? Who else got it? Garrison, you get it? Did you get it? Yeah. What did you say?
I put 8x squared minus 1 squared. I think that's right.
No. Joby. 4x minus 1, 4x plus 1. Okay. So 4x, he said minus first, it doesn't matter. Remember, this could have been rewritten like 4x in parentheses squared. And then what number squared equals 1? 1 squared. There you go. So it does fit the pattern. It's something squared minus something squared. And you just roll it out. But you got to recognize your perfect squares. You got to know what they are. And when if you're factoring and you suspect that something might be a difference of squares, you know, maybe you should, like with your calculator, make a list of all the perfect squares just to compare. How could I make a list of all the perfect squares? How about go to y equals and then put x squared. X squared. And now when I go to the table of values, there they all are. So if you're suspicious it might be a difference of squares, see if the numbers are there. Okay, then we also had the perfect square trinomial, which factored as 1 factor squared. But last class, the a was always 1. So it didn't really, it was a pretty easy problem. Now, it can be a little more difficult. These problems in particular aren't really that difficult because, you know, if you didn't recognize this as a perfect square trinomial, then you'd probably go back to what we did at the very first of this class, right? Which was multiply a times c, find the factors that add up to the middle number. And it would work. I mean, in this first one, 4 times 25 is 100. Can you think of factors of 100 that add up to 20? 10 and 10. I mean, so it would work. But sometimes these numbers get way bigger than that. And you may not want to go through all of that. What I would do is I would look at it and say, does it look like the first term could be written as a square and the last term could be written as a square? 4y squared and 25? Aren't those both perfect squares? So that tells me that there's a good chance that what I've got going here is 2y plus 5, 2y plus 5. That would certainly give me the first and the last term. Does it give me the right middle term? It gives me 2y times 5 is 10y, and then another 5 times 2y is another 10y, so there's 20y. So yeah, that's it. So in fact, this is 2y plus 5, parentheses, squared. Right, the second one, the first coefficient is 36 and the c is 1. Aren't those both perfect squares? So what do you think might be the factoring of it? 6w plus 1 squared? Incorrect. What's incorrect about it? Yeah, because the middle term is negative, I think we need that to be a negative. I mean, there's only two possibilities, right? It's either going to be plus or minus in the middle term, and that would change that factor. So make that a minus 1. So let's see, 6w minus 1, 6w minus 1. And again, the first and the last terms are fine. Now if I do the middle term, I get negative 6w minus 6w, which is minus 12w. So that's correct. So, I mean, you could go through that 5 or 6 step process to do it, but if you recognize the pattern, you might get it a lot quicker than that. So try to do that one. So is the first term a perfect square? What would it be? That's like 5s in parentheses squared. How about the last term? Yeah, it's either got to be 8 or a negative 8, and since the middle term is negative, we're presuming it's like this, right? And then according to the formula, right, the formula was this. A squared plus 2ab plus b squared equals a plus b squared. So in fact, this middle term should be plus 2 times 5s times negative 8. I got to rewrite that. Plus negative 8 squared. And does that work out? Let's see. 2 times 5 times negative 8 is negative 80. so it works. So this whole thing is just 5s minus 8 squared. So just look for the first and the last terms. If they're perfect squares, you know, you could probably take a guess it's either 5s minus 8 squared or 5s plus 8 squared. And don't confuse this with difference of squares. Right? That's the one that would have been like 5s plus 8 times 5s minus 8. Okay. So now, like we saw in the homework, we saw some greatest common factors that we had to take out. And we will have to do that here too. So let's just do a couple practice of that. The first one, what's the greatest common factor? It looks like there's a 5, right? So if I factor a 5 out of both of those terms, what's left? X squared minus 9. Okay. Now, can you do any more factoring? How could you factor what's inside parentheses? What factoring pattern is it? It's the difference of squares. So you've got to keep going. If there's more to do, then you got to do it. So what would this be? 5 times x plus 3, x minus 3, like that. Usually, like on a, I don't know if in the textbook, but like on a test, if I'm thinking that there's like more than one layer of factoring, the directions will say completely factor to make sure that, you know, you take it all the way to the end. How about the second one? What's the greatest common factor between those two? 5z. Okay. Well, let's see. You could say 5z. What else could you say? What about negative 5z? Okay. If you do positive 5z, then you're left with negative z plus 4 plus 4. If you take out the negative, then you'll get z minus 4. I think normally you would expect that they take out the negative. So any more factoring you can do there? I mean, z minus 4, there's nothing in common. Can't do anything. So factor completely. Is there a greatest common factor on the left? What is it? 2. Just 2, right? So I take out a 2, and now I've got 3q squared minus 7q plus 4. So then you have to ask yourself a question. Is what's in parentheses factorable? If it is factorable, then because a does not equal 1, it's going to have to be that long process, right? So remember what you do to determine when you're factoring like that? The first thing is you multiply a times c, and you find the factors of that add up to the middle number. So if I do that here, 3 times 4 is 12. Are there factors of 12 that add up to negative 7? There is. That means it's factorable, so you have to keep going. Okay. Now, you could at this point, if you wanted to, you could guess and check. Right? That would work. But I think I'm going to do the long process, right? It would be 12. And it looks like those factors, those numbers would have been minus 3 and minus 4. So this is 2 times 3q squared minus 3q minus 4q plus 4. Group 3q squared minus 3q minus 4q minus 4. Factor. Greatest common factor, 3q times q minus, what's left? If you factor 3q from 3q, what's left? 1, right? Not nothing. And then minus 4 times q minus 1. And then finally, this is 2 times 3q minus 4 times q minus 1. Remember that 2 you took out at the beginning. that's still there. In a factoring problem, you can't get rid of that 2. Right? So just that goes along for the ride. You know, if you don't show it in all the intermediate steps, that's okay, but just make sure it's in the last answer. How about the next one? Is there a greatest common factor? It looks like there's a 3, so we take out a 3. 4p squared minus 7p plus 1. So we got to do that same check. Is it factorable? Are there factors of a times c that add up to b? In this case, are there factors of positive 4 that add up to negative 7? No. So you're done. Sometimes that's all you can do is just take out the constant. So this part here is not factorable. Let me say it like this. Not further factorable. Is that yours?
Yeah.
So try that one. Did you find a common factor? 3. So what's left inside the parentheses if you factor out a 3? S squared minus 8. Okay, so if that's factorable, s squared minus 8, it would only be if it was a difference of squares. Is it a difference of squares? So you're done. Can't do anything more with that. So you just take out a 3 and be done. Okay. Doesn't mean it's not solvable, because when we start to get equations that have that on the left-hand side, we still have to keep solving, but we just can't factor it. Okay, try that one. So what was the first step? Factor out of 4, right? That should have left you at 3x squared minus 7x minus 6. Okay, is it further factorable? Are there factors of negative 18 that add up to negative 7? And if so, what are they? Negative 9 and 2. So 3x squared minus 9x plus 2x minus 6. Again, I chose to put the negative term first so that I have a plus in the middle of the parentheses. And that means I can actually group on this one same line. I can group, and I don't have to flip the sign of the last term. It works out just fine. Okay, now, factor the first set of parentheses. What is the greatest common factor? 3x times x minus 3 plus 2 times x minus 3. So we have 4, we have 3x plus 2, and we have x minus 3. So let's go ahead then. So that's kind of all the different kinds of factoring. Now we have to solve equations by that kind of factoring. So just like I said, well, I don't know if I said it. On problems like this, if it says factor, don't set it equal to 0 and then tell me what the answers are. That means you don't really understand. You're just throwing everything at the wall. And on problems like this, if it says solve, you're not done until you say x equals, right? Whatever the values are. So solve by factoring. Remember that in order to do this, we have to start with standard form equals 0, so that we end up using 0 product property. Okay, if this is factorable, then I got to multiply a times c. That's negative 24. Are there factors of negative 24 that add up to 10? Remember, one's got to be positive, one's got to be negative. Try that. How about positive 12 and negative 2? Right? I mean, all the factors of 24, which has quite a few, are like that. Since they're going to add up to a positive number, I know that it'll be the smaller number, which has a negative. And then the one that adds up to positive 10 is that one right there. So here we go. 3x squared minus 2x plus 12x minus 8 equals 0. And group 3x squared minus 2x plus 12x minus 8 equals 0. X times 3x minus 2 plus 4 times 3x minus 2. So here's the last step of factoring, x plus 4 times 3x minus 2. Okay, but now we're not done. Now we get what values of x would make this equation equal 0? Well, what would you plug into this x right there to make x plus 4 equal 0? Negative 4. You could probably visually see that no matter what. You're just going to say negative 4. Now, you may have a harder time with 3x minus 2. If you do, then make yourself a little equation, right? 3x minus 2 equals 0, and solve it. 3x equals 2, x equals 2/3. But if you actually can see that, you know that, hey, if I put in 2/3 for x, the 3's would cancel, and then it would be 2 minus 2, 0. Okay. If you can see that, you don't have to write an equation off to the side. But the correct answers are negative 4 and 2/3. You know, if a is not 1, then you're going to have a fraction. In the end, you know you're going to have a fraction as an answer. Now, I think if you go back to the objectives for this, you know, what they say is we've got to be able to factor completely over the integers. What they mean by that, it's not that you have to get integers for answers. Clearly, 2/3 is not an integer. It's that the equation up here can only have integer coefficients. They would never throw at you something that had fractions for a, b, or c. But the answers can definitely have fractions. Okay. This is probably... Did I miss one? No. Okay, what if we had to solve this one? What's different about this one than... It's not equal to 0, so how do I make it equal to 0? Well, I would have to subtract 4p and add 5 to both sides, assuming we're going to make the 0 on the right here. So subtract 4p and add 5. Subtract 4p and add 5. So now we have 5p squared minus 20p plus 20 equals 0. Okay? So any factoring jump out at you there? There's a common factor of 5. Okay? So now, I can certainly factor that out. Right? If I take out a 5, I'm going to get p squared minus 4p plus 4 equals 0. But because it's an equation, actually you don't have to factor out p. You could just divide out a p. Right? Because when we do the 0 product property, we're going to have 5 times this factorization that we have, right? There's no way 5 is going to be the source of the 0. 5 does not equal 0. And if we divide both sides by 5, what do we get? What's 0 divided by 5? It's 0 anyway. So we could actually get rid of the 5 in this case. Just don't confuse that with if you're doing a factoring problem like that one where you had a 4. That you can't drop. That's not an equation with 0 on the other side that you could just like get rid of it like we're doing. But if it's an equation, you don't have to factor it out. You could just divide it out. Meaning, I could have at this step here, let me go like this. I could have at this step here just say divide by 5, divide by 5, divide by 5, divide by 5. And then I would have had my p squared minus 4p plus 4 equals 0. No 5s. And how would that last thing factor? I mean, at the very least, it's a simple quadratic trinomial. What are the factors of 4 that add up to negative 4? Negative 2, negative 2. That's actually a perfect square trinomial. So what is the only answer? 2. Yeah, 18, 19, 20. Got 2 more slides. So you try to do that one. So we should all get that far. You know, subtract the x and the 8, and then divide out a 6. You don't need the 6. Right? And then how do you factor something like that? You could go through the long process. You know, 2 and 1 are both prime numbers. It really wouldn't take long to just guess and check it either. Right? If I went 2x here and x here, you know, the last is either got to be a +1 and then a -1, or a -1 and a +1. And which one is it? I think it ends up being -1 + 1. Let's see. 2x times 1 is positive 2x. Minus 1x is x. So that's correct. So I just guessed and checked that. Okay, now I'm not done until I say what does x equal? Right? And x equals positive 1/2 and negative 1. The negative 1 you can see for sure. If you don't see why x equals 1/2, then take 2x minus 1 and make it, set it equal to 0 and solve. 2x equals 1, x equals 1/2. Last slide. So this is an example in the book, but because I don't have access to the digital book anymore, I just have to draw it myself. You have made a rectangular quilt that is 5 feet by 4 feet. You want to use the remaining 10 square feet of fabric to add a decorative border of uniform width to the quilt. What would be the width of the quilt's? What would the width of the quilt's border be? So we have to make a little equation there. First, if you look at the picture, the inside dimensions of the quilt, right, as it exists, is 5 times 4. And we're going to add a strip going all the way around the outside, which total has an area of 10, because that's how much fabric you've got. So we know that that total area is 20 plus 10, 30. Okay, but we don't know how wide those strips are to the top and bottom or left and right. So we can set use variable expression here, right? The long-wise, the length, it'll be x plus 5 plus x. That's 5 plus 2x. And on the top and up and down, it'll be 4 plus 2x. So it must be that 30 equals this 5 plus 2x times 4 plus 2x. So let's solve it for x to see how big of a border we can come up with. Okay, at this point I have to FOIL. 5 plus 2x, 4 plus 2x. That'll be 20 plus 10x plus 8x plus 4x squared. Okay, let me combine like terms. Rewrite a little bit. This is 30 equals 4x squared plus 18x plus 20. So 0 equals 4x squared plus 18x minus 10. So are there any common factors? So we could just simplify this before we get going. Looks like you could take out a 2. So let me divide out a 2. 0 equals 2x squared plus 9x minus 5. Okay, if it's factorable, then there must be factors of negative 10 that add up to positive 9. Are there? 10 and negative 1. Okay, so that would be 10 times negative 10 breaks into negative 1 times positive 10. So we write it 0 equals 2x squared minus x plus 10x minus 5. Group the first two terms, group the last two terms. Make sure that plus is in the middle of the parentheses. Factor each set of parentheses. 0 equals x times 2x minus 1 plus 5 times 2x minus 1. So we're almost done. 0 equals x plus 5 times 2x minus 1. So if we solve the equation, we're going to get x equals, from the first factor, negative 5. From the second factor, not 1, 1/2, right? 2 times a half is 1, minus 1 is 0. Okay, and then there's one of those answers you can throw out. Because which answer doesn't make sense? Negative 5, right? It's going to have some positive value for a border, right? Not a negative 5. So we can throw that one out. Right? And the only answer is 1/2. Allora, that's it. So that's the homework. Next class we will have a quiz on factoring. That is all the factoring we do in this class. No, for quadratics.